Hello class, welcome back to another flip lesson. Today we're going to talk about arithmetic and geometric sequences. We know from one of our vocabulary words that a sequence is a list of numbers in a specific pattern, and we're going to determine if that is an arithmetic pattern or a geometric pattern. So have your notes and something to write with. If you haven't done so already, complete the review it section. And then we're going to talk about what we need to know. So when it comes to sequences, first I want to know a little bit about the words, the terminology, so we can understand these notes. So we have sequences, and we want to know what a term is. Term is also one of our vocabulary words for this week. And when we have a sequence like we do here, each number in this sequence represents a term in the sequence. The starting one is the first term. Next we have the second term, third term, fourth term, and it doesn't matter what number is in that place, it's still the first, second, third, fourth term and all the way through the sequence. So I'm going to be using the word term, so be sure you understand what it means. Now we need to find a pattern for our sequence. So looking at the pattern, we want to look at those numbers that are listed, and the thing that we want to look for is it increasing or is it decreasing? And by knowing whether the numbers are increasing or decreasing will really help us figure out what we're doing to each term, to each following term. So if the numbers are increasing, we can figure out that a positive number is being added. That's important to realize, that we are adding on increasing positive numbers, and we're going to add it to each term, or an integer is being multiplied. So depending on what kind of sequence we have, arithmetic or geometric, we will either add or we will multiply. This will become clearer later on in the lesson. Now if the numbers are decreasing, if the numbers are decreasing, a negative number is being added. Again, we're going to add to each term. Or a fraction is being multiplied to each term. Again, it makes a difference whether it's arithmetic or geometric, whether or not we add or we multiply. So let's figure out which type of sequence do we have. Is it arithmetic or geometric? Well, what makes it an arithmetic sequence is that it's going to have a common difference. Basically, the common difference is the rule that we use to get from one number to the next number. So we're going to use that common difference to add to each term. In a geometric sequence, we will use a common ratio. And when we do a geometric sequence, we use that common ratio to multiply to each term. So it's very important that we make that association, that arithmetic sequences use a common difference to add, geometric sequences use a common ratio to multiply. And when I see the word difference, I think of adding, subtracting, of course, but then it also has an opposite operation called adding, so adding and subtracting kind of go together. And when I think of a ratio, I think of division, and division and multiplication are inverse operations, so they kind of go together. That's how I remember which one I'm going to use for each sequence. So let's try out these sequences on the next page and see if we can figure out the common differences in the ratios and the types of sequence. So we have these numbers 8, 11, 14, and 17. Now these are the same numbers that are from your review section. So if you did the review section, you should be able to have the rule already. And so we know that the rule for this is going to be adding 3. So I add 3 to 8, I get 11. I add 3 to 11, I get 14. Add 3 to 14, and I get 17. Now when you are adding a number, you are using an arithmetic sequence. An arithmetic sequence has a common difference. And I want to know what that common difference is. Well, if I'm adding 3, you don't write, this is the rule when you put the plus sign for adding 3. So you just write 3. That's the actual common difference. Because arithmetic sequence will always add. So we don't have to write the plus sign, we just write the 3. Let's look at the next number in the sequence. 2, 4, 8, and 16. Well, I could add 2 and get 4, but if I add 2 again, it would be 6. So I know it's not an adding sequence. So I could figure out that it is a multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So